Hello everybody! I hope everyone's having a beautiful day. For today's lecture, we're going to be talking about debugging. Now, before we get into debugging itself and what's that about, I need to give us an idea where we currently are. So, presently we've written some computer programs. We've seen some of the basic elements of what makes a computer programming language, such as Python. So, for example, we talked a little bit about control statements. We talked a little bit about, for example, loops. But I want to kind of take it back even further, just to some of the things we might have talked about at the basics of what programming is all about and how we can translate our ideas to a computer program, because that plays a big role in what we're going to be talking about today. So, a couple of things. The first thing is just recall that whenever we write a computer program, the big thing is that there cannot be any ambiguity. So when I laid out a set of steps for my computer program, when I translate those over for Python, they have to be able to be interpreted one singular way. There is no multiple ways of interpreting the same set of steps. There is no ambiguity. The other thing is, when we are writing our computer program, there could be a couple things that could go wrong in that process. The first thing is we could, for example, violate the rules of the programming language. So I could express something and attempt to do it in Python, but it doesn't actually follow the rules. We're going to talk a little bit about that today. It's called syntax, for example. Second, even if we follow the rules of the programming language when we translate our ideas into a computer program, there's a possibility that there's actually an error, an unintended outcome from the program. This could happen during the execution of the program, or even at the end, we see that the outcome or result that we're expecting isn't there. So that brings me to what a bug is about. So there's this phrase called a bug. In software development, it's an error that causes an unintended behavior when designing a computer program or system. Now, this term bug goes all the way back. It's a general engineering term that even goes back to Thomas Edison. You can find letters with Thomas Edison talking all about this stuff. Say, we were talking about stuff way back, talking about Orange Lab. But the point is, it's a broad term, but in computer programming, it's usually talking about unintended behavior. So this is a broad class of possible things that could go wrong. So, for example, that could be that during compilation or parsing, if we're talking about Python, so-called compile time, there's a possibility that a bug can occur. And if that does happen, then the program doesn't compile. Likewise, there's always a possibility that at runtime, that means when your program is running, or any time at that includes up to the end of it, an error that could disrupt your program, including it to cease entirely, or even go into an infinite loop, can happen during runtime. Those are so-called compile time errors and runtime errors, respectively. Now, you might say, Dan, you mentioned about how even if the program completes, there's a possibility that there could still be errors, yes? Well, those fundamentally are based on our ideas. So even after execution of the program, there can be errors. And these errors are called logic errors. Makes sense. I mean, it's about our ideas. So the ideas we implement to try to solve a problem, they actually may be incorrect fundamentally. It didn't matter if Python doesn't know what we're writing down, or Python just follows some set of steps and makes a mistake. Fundamentally, even if the program terminates correctly, it may be that the output is incorrect. A logic error. So I just wanted to mention a couple quick things before we get into all the bits and pieces today. Is Python facilitates reporting errors using something called an exception. We'll talk about these at some point, but not today. Not today. So I've included some documentation for your interest if you're curious about exceptions or handling exceptions. I'm not going to talk about exceptions per se here, but they're one of the underlying aspects of how Python reports errors to the programmer. So one other thing I need to bring up is, what does it mean to debug then? So if I have logic errors, compile time errors, runtime errors, all of these are different kinds of bugs. Now in Python, because Python is compile time and an interpretive programming language, oftentimes these two can blur sometimes of what is one versus not. I'm not going to focus so much on that here, but the point is that debugging is the activity of resolving. I was thinking of what word I would like to use here. I'm going to use resolve, just be a little bit gentle with our bugs, of resolving bugs. So it may be the case that you might get all of the bugs, but the point is it's just an activity of removing these bugs. So that being said, I just wanted to mention a couple other things here. So the big thing that I really wanted to hammer in, and this is a big, I'm going to make this as a, if there's one thing to take away from this lecture, so this is a big, I want you to put stars around this in your notes, okay? So put stars around this. is just because the program compiles does not mean is error-free, meaning that we don't have any bugs. Oftentimes, just getting the program to compile is one of the first steps in debugging. Once you've got that past that step, you're going to have to deal with potential errors. And keep in mind, debugging is a typical activity of a programmer. So don't downplay the significance of this. I will most certainly not. Even with my years of experience, most certainly I still have bugs in my code sometimes, even how careful I can be, because of, like I said, when we write our computer programs, it requires us to be unambiguous with the way we describe things for Python. So that makes a possibility of one of our ideas, even if we had the right idea, it might be just slightly off from what the actual outcome should be. So let's talk a little bit about Python itself. So the first thing I wanted to do is bring up so I got Google Colab here, and I have some Python code here. I got a main function. I got this function called hello world, and I call main for this program. Now, you might look at this and say, Dan, what am I supposed to do here? Now, you might be inclined, I'm just going to try to start up running the program, but you'll see that it actually cannot compile. The parser can't handle this. It says up down here, if you look down right about here, about way down there, just keep going, it's near the bottom. You'll see that it says line 9 message, and it says hello world. You'll see a little caret, a little arrow pointing at where it starts with the M. Now, Python's interpreter tries to help provide information for you to know where the error is happening. Now, like I said, we're just talking about these compile time errors at this stage because I've attempted to compile the program. So it says here that there's an indentation error. So it says expected an indented block after function definition on line 8. Well, let's look at it. Remember what we have to do with our functions. We have to do what? What do we have to do? We need to make sure we indent in a block of code. So you'll notice right away, you'll actually notice, let me put it back. If you hover your mouse over this in some integrated development environments, you'll actually tell you what the error might be, because these can be determined before executing the program. So now if I try running this, it prints out hello world as expected. Let's start talking about some kinds of errors. Now, these are not all of them. These are just some common types. I've included a link to more examples of types. I encourage you to check them out. Rather than writing about them each on the board, because we have a short lecture here, I'm going to go through each type and I'm going to show you some examples of how we can resolve them. That's what we're going to do the remainder of our time, and I'll leave a little bit at the end to talk a little bit about techniques for debugging. So I thought the first thing to talk about was syntax errors. In fact, what I just showed you here, an indentation error is in fact a kind of syntax error. Do you notice that Python would have a very hard time figuring out where, and I keep in mind I'm talking more colloquially here, is that it has a hard time determining, okay, is this a part, is this line 9, is that a part of the hello world function? Well, we know that we have to indent in so that our block of code is associated with the function, right? Likewise, we have to make sure we use keywords that Python can recognize. So for example, I can't just simply write this, right? Sure, I could be really busy one day and just quickly trying to jot down some code. If I have 2 F's here, Python don't know what that is. Doesn't know what a def is. It knows what a def is, right? So notice it's just not, this isn't one of the keywords. So notice that another helpful way of looking for this is when you're looking in a development environment, sometimes these keywords get highlighted. But regardless, if I try to compile this, let's try compiling it, you get a syntax error. And it tells you right there. It tells you the earliest point it can. It tries to do it towards the left, or it tells you a line number, for example. It tries to give you some helpful suggestions even sometimes. But I'll give you a warning, not every suggestion it makes can be correct. In fact, sometimes it can mislead you. I included in the notes an example of one such case. So the next kind of error I want to talk about is the so-called name error. Let me just do a quick example here to illustrate the point, and then I'll tell you what it's all about. So suppose I wrote a program, or attempted to write a valid program that does the following. So assign z to be x plus y, and where x and y are 5 and 6. Let's try to compile this, and we get a name error. So what does it say? It says name x is not defined. So you might ask, now, what is a name error then? Well, it's simply that when Python is attempting to look up or find a name, which keep in mind, a name might be a variable, it might be a function, it might be a method. The point is that it doesn't find the name it needs at the time for which it's going to be executed. And that's what a name error is. So there's different versions of name errors, but that's the primary idea. Python might have some trouble if I try to do the following. Say I wanted to print out 42 is the answer. I want to print out that sentence. Let's try printing that out. Oh, getting a type error. It says unsupported operand types for int and str, string. So what do we do here then? Well, it's telling us that there's an incompatibility between these two types, and that's what happens when you get a type error. Is you might be meddling with 2 or more types that might not be compatible with each other. A common way this can happen is in such situations. So I have a number. I would like to print the number with a string. I would use the str function to convert that over to being a string representation of the number. And notice now it says 42 is the answer. So that's what type errors are all about. So just be mindful of when you use types. Numbers like floats and integers, they get along very well, but strings and numbers, ooh, make sure you use str, okay? I wanted to quickly address basic strategies. So I wanted you to do one example, but I want to highlight a few main things before we go. So a big mistake often when somebody's starting off programming, a big mistake very often is to simply take and write out as much of your code as you possibly can at that time. And then you're like, okay, well, I wrote up all my code, I'm going to try compiling and I'm going to run it. Well, you'll run, if you have errors, there's a possibility errors that you correct can cause more errors. That's another possibility. So one suggestion I can give you is start small, write some small lines, maybe write one function, test your function, try it out with some examples, kind of like what we did here, and see if it works or not. Does it make sense? One of the biggest things that students overlook, and this is something I've seen for years, and I always tell students, and they thank me so much afterwards, is remember, your best friend is pulling out a piece of paper, a pen and a pencil, and walking carefully through your code. Make no assumptions about your code, and don't be afraid to test your code. You need to run your code. Just compiling it doesn't mean it's going to be correct. There's a lot more mathematical machinery needed for demonstrating correctness. That's beyond the scope of this course, but most certainly getting it right for a lot of the problems we're talking about doesn't require such rigorous attitude. Just be careful. That's where I'm going with this. If you write some code, give it a try, test your code, but test as you're implementing, if possible. Now, if you do have errors, try to incrementally fix these errors, but don't like try to do them all at once. Try to take on one, see if it improves the situation. But remember, at the end of the day, you don't want any bugs in your code. And this can be a rather time-consuming process if you're not careful, but it happens to everybody. The biggest tip I can give you, and this is one that has helped me so many times, is explaining your code to someone. It can even be my little dinosaur friend here, sitting at your desk, and you can talk to your dinosaur friend here, telling him about your code. So just talk about your code, walk through the reasoning of your code, even if it's your dinosaur friend right here, walk through it with them. And sometimes the errors pop out and you're like, whoa, why didn't I think of this? I'm going to show you a simpler technique that you can use in tandem with this. I'm going to do a quick example here, and then we're going to wrap up here things. I have this example where I'm performing an arithmetic sum. So I want to get the sum of non-negative integers starting from 0 up to some integer n. So I have this function here called arithmetic, and it gets a non-negative integer. And what it's going to do is it's going to do what I just said. It's going to add up the numbers 0 to 1, 2, 3, 4, all the way up to n. So I put some preliminary tests in. So this is just some tests I wrote up. They're really basic. They're not using any fancy features. And I just want to see, does this function? So let me walk you through the idea behind it. So I start off with sum and count. So count is going to be used to count how many numbers I've added up to so far. So I start off at 0, then I go 1, then I go 2, then I go 3, then I go 4, and then I go 5. And I want to go up to n, but I don't want to go past n. So that's why the condition on this while loop, it says, well, count is less than n. So I wanted to see what this does. Well, for n is 0, it worked, but all the other ones, it fails. But there's a problem here. A surprisingly effective technique you could use in debugging is by incorporating print statements. And you make an educated guess of what you think should happen at that time. You can put before and after a statement, prints of values that you're interested in or any other data that you're curious about during the execution of your program, and see what happens. So you'll notice very clearly there's something else going on here. And I don't know what the sums are. But one thing I do know as a matter of fact, if I look carefully at my program, is that sum gets added, count gets added to sum as a running total, right? I keep adding count to it. So that plays a very big role in how this works. So what I'm going to do is I'm going to put a print statement here, and I want to find out what what count looks like. Because remember, it should be like, for example, if I give you 1, it should add 1. If n is 2, it should be 1 plus 2. No, is it 1 plus 2? No, if n is 2, it's 1 plus 2, right? If n is 3, it's 1 plus 2 plus 3. Well, let's see what happens if I try printing. I want to see what it's adding to the running total so far. Well, you'll notice that the test print always happens at the end. So you'll notice that the 0 that happens immediately after our first line here, that's for n is equal to 1. So notice that it's 0, then for n is 2, it's 0 plus 1. For 3, it's 0 plus 1 plus 2. There's something off here. Do you see it? It's 1 off everywhere. It should be 1 plus 2 plus 3 for n is equal to 3, for example. It looks like I have these two lines out of order. It looks like the count should be 1 higher inside of here. It won't affect the while loop because regardless, it will go through all of the indented parts here, come back up and check the condition of count is less than n. So let's see what happens now. Boom, there we go. So I encourage you to go through the same exercise we just did here with paper and pencil. Walk through what that while loop is doing before we made the appropriate change. One thing I'll mention, I included a link to the Python debugger, which actually uses a concept very similar to this called breakpoints. So where you could assign lines for which this debugger will stop at, and you can find out what variable, like what values certain variables have. All I know is it's pretty exciting stuff when you really get down to it, and good luck with writing more computer programs. So have yourself a beautiful day. I'll see you later.